Very good morning, my dear friends. Myself, Dr. M.H. Annaya, and in today's video, we are going to work out a very interesting problem on the development of a right circular cone. And the question for today's video reads like this: a cone of diameter of base 50 and axis 70 mm, resting on HP. An ant starts moving from a point of the base, moves around the curved periphery of the lateral surface by the shortest route and returns to the starting point. Draw the path traced by the ant in front and top views of the cone. Friends, first of all, let us write down the top and front views of the cone to the given dimensions. And this is the top view of the cone, which has got a diameter equal to 50 millimeter. We'll call it as 550. That means diameter is 50 mm. And I have divided this into 8 equal parts. We'll mark as A, B, C, D, E, F, G, and H. These are the 8 divisions on the periphery of the base. O is the center, that is the apex of the solid. We'll transfer all these points to the front view and obtain the front view of the solid, that is a right circular cone having height equal to 70 millimeter. So I'll just mark somewhere here this height as 70 mm, 70 millimeter. The apex of the solid is O, let us O dash. Transfer these points also. So this is the point C and G, C dash, G dash, this is E dash, A dash here, E dash, B and H fall on this, similarly D and F. So we'll join all these points on the base to the apex O. So here you will have the point B comma H, etc. So I will say here this is B dash comma H dash, this is CG, this is D dash comma F dash. Friends, this is the top and front views of the cone. We have done a lot of such problems. Now the question is, there is an ant. It starts moving around the periphery by taking the shortest route. So friends, we will draw the development of the cone without being cut by any section plane. And further friends, we have the formula. The included angle or the sector angle theta is equal to small r by capital R into 360 degree, where r is the radius of the base, that is diameter by 2. R is equal to 25, and this r is the length of this generator, true length of the generator, which can be obtained after construction of the figure. You can obtain this r, put the value of r, then you will get the value of theta. So you will get some degree. So we are going to get the subtended angle of the sector at O, the apex of the solid. Now after getting this value, friends, let us draw the sector or the lateral surface of the cone, assuming it is not cut by any section plane. So this is how we are going to get this sector with apex O, and this is the true length of the generators. We have divided this into 8 equal parts. So also, let us divide this sector having angle theta into 8 equal parts. That is, this is 4. Again, in between one division you can have exactly in the center, and you have got the sector theta divided into 8 equal parts equal to the number of parts the circle is divided into. And friends, let us say the ant is going to start moving from here, from the point A. I will say this as point A. The last one is point A. And then you have mark B, C, D, E, F, G, and H. The ending and the starting point should have the same marking. So now, friends, the ant which is starting from here, it will move along this periphery, reach the maximum height somewhere here, then move back in the same similar path on the other side of the cone and reach the point A. So to start with, let us say it is starting from the point A. So I will mark point A here, one point here, another point. So I will call this as point 1. This is point 1, and again this is point 1 in the top view. Friends, while traveling along the periphery of this right circular cone, it has to take the shortest route. That is, it has to go from A, go along the periphery of this one, and move back to the same by the shortest route. So A to A, the shortest route is this straight line connecting these two. So this is the shortest route. How this has to go from A to B to C, D, E, F, G, H, and again back to A. This is how we should do. Friends, this is nothing but something like a curved periphery or curved section plane which is going to cut this solid. So what we'll do, you mark point 1 in the front view, top view, and on the development. Next, friends, we have got this point 2 on OB. 2 is on OB. OB is here. But friends, this OB is not true length. But this is the development drawn to true side. So we will mark this distance B2, B22 on one of the end generators, which is true length. Say, you can just mark here or here, no problem. So I will mark the distance from there. This is a true length. This distance is equal to this. And then shift that to that point. So this is the second point on this slant edge, that is OB. So I will call it as point 2. This one here, point 2. Then friends, you have got this point 3 on OC. OC is also not true length. So we have to shift that distance C to point 3, 3C on that last generator from here to here, say, and shift that to the true length line. This is the point we have got. On the true length, shift that to the CG. So this is the next point. So I have to mark all these distances from the curved periphery onto the corresponding generators after shifting them to the end generator. So 1 I have marked, 2 I have marked. I have taken the distance of 3 on OC. That is that distance I have shifted here. This measurement I am going to take here. So this is point 3. Friends, 4 is on OD. 1, 2, 3, 4. Point 4 is on OD. So this is A, B, C, H. D is here. Again, this is take this measurement on the last generator, either on this OA or on OE. And friends, shift that to, because this point will move little up. So maybe somewhere here you are going to get the point. Shift that to the point D by a horizontal line. So I am getting this point. 1, 2, 3, and this is point number 4. 1, 2, 3. This is point number 4. Finally, friends, OE, this distance OE will be the maximum compared to any of these distances. So this OE is the true length. I take this point 5E, point 5 exactly on this, say somewhere here. That point is 5. So 1, 2, 3, 4, 5. You got these 5 points. Then friends, it has to move back. Then 6 comes on OF. Point 6 OF. So the distance of OF, sorry, this point 6 and F is same as this 4 and D. So it will come back. Then from here it will come back. It's moving on the other end. After traveling in the front phase, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 1. So friends, this is how the ant is going to move in a curved periphery along the lateral surface. So this is the front part. And the second, the back side also, it is going to retrace on the same curved path back side also. So friends, let us take these points on the top view. One we have got, and we have got this is 5, 6, 7, and this 8, and this is 1. So friends, here on this you are going OB, OH, you will get 2 points. OB and OH, you will get 2 points. And similarly on OC and OG, you will get 2 points. So that is lesser than that. That is, you can shift this point, take this point on this, and you can shift there to the vertical lines. This is how you get. And again, friends, the distance keeps on decreasing along this. So you will have 2 more points here, then 1 point here on OE. That is, you take this point, will touch there. So friends, join all these points so obtained by a smooth continuous curve. This is how the curve is going to be. So it will start from this A, move along this, move along, then reach back the same point. So these are the points. This is 2 on OB, 3, 4, 5, 6, 7, 8, and 1. This is how the path of the ant in the top view appears. So this is the curved path in the front view, and by following the shortest route, that is from A to A, this is how the path traced by the ant looks in the front and top views. Friend, it's a very interesting problem on the development of cone. And please go through the complete video. And if you like this video, do share with all your friends without fail. Have a wonderful day.